Becoming a cell might sound relaxing at first. No schedules, no emails, no taxes. Just floating around inside a soft, temperature-controlled bubble, while everyone else does something vaguely important. But the truth is, being a cell isn't always a walk in the park. You might find yourself bumping into proteins you can't pronounce, getting nudged by mysterious floating blobs, and wondering deeply if you're supposed to be doing something. Spoiler, you probably are, but no one's explained what yet. Before we begin, where in the world are you listening from tonight? Drop your location and time zone in the comments. It's always strangely comforting to know where fellow drifting minds are floating in from. Now, wherever you are, get comfortable. Lie down somewhere soft, quiet, and safe. Let your limbs grow heavy. Let your breath soften. If you have an eye mask, go ahead. Slip it on. Block out the world for a little while. You're about to become a single, squishy, slightly confused cell inside the human body. No expectations. No rush. Just a long, slow journey through warm cytoplasm and unspoken responsibilities. Let's begin. You wake slowly. Not the kind of waking that involves alarm clocks or groggy blinks, but the quiet, confused arrival of awareness. One moment you weren't anything, and now, well, now you are here. Suspended. Floating. Conscious somehow, inside what feels like a room made of warm pudding. The walls are soft, if you can call them walls. There's no ceiling, no floor. Just a strange, jellied suspension that gently moves around you, carrying odd bits of microscopic furniture in no particular order. You don't have eyes, but you can sense things, the way a dream senses a landscape without really seeing it. You take stock of your situation. You're small, extremely small. Your entire world is the inside of a single cell in the human body. You don't know whose body. Maybe it doesn't matter. You're not in charge. You're just in it. The space around you is filled with other objects. Tiny, shapeless things that seem busy, each doing something repetitive, mildly important, and generally unhurried. They move with a kind of tired purpose, like co-workers shuffling to the break room, but in slow motion. This is the cytoplasm, the gooey interior of the cell. It's less glamorous than it sounds, sort of like an overcrowded soup that forgot it was supposed to be clear. Everything inside the cytoplasm is suspended: organelles, proteins, enzymes, and occasionally something unidentifiable that bobs past like a lost sock in a dryer. The fluid is thick but not sticky, warm but not hot. It feels like room temperature for a room that was never built. The movement is constant and strangely comforting, like the gentle sloshing of a boat that's never docked. Something blobby brushes past you. It doesn't stop, it never does. Nobody here really says hello, but then again you're not sure you have a mouth. You might not have ears either. It's a lot to process. Still, you start drifting, just slowly enough to not feel like you're doing anything. You're carried by the current of the cytoplasm, which shifts like molasses with opinions. Every now and then, a little ripple forms, possibly from a nearby reaction. You don't know what kind. Probably important, probably none of your business. You bump into something vaguely folded and irregular. It's soft, squishy, and unbothered by your presence. It might be part of the endoplasmic reticulum, though you're not ready to commit to names yet. It hums faintly. Not in sound, but in energy. Like a tired machine that never fully powers down. All around you, particles twitch and curl. A ribosome clings to a nearby membrane, turning amino acids into proteins, with the quiet concentration of someone building IKEA furniture without instructions. The protein it's assembling is, as far as you can tell, completely unaware of the drama involved in its creation. You try to introduce yourself, but ribosomes aren't known for their conversation skills, or any skills beyond protein assembly. Still, it's comforting to know someone around here has a job. Above you, or maybe beside you, directions are irrelevant. A small glowing oval pulses faintly. It's a mitochondrion. You've heard things, it's got a reputation. Powerhouse of the cell, they say. It radiates energy and self-importance in equal measure. The mitochondrion doesn't talk to you either, but it feels busy. Not hurried, just smug. You get the sense it'd be exhausting at parties. Other organelles drift by with less fanfare. Vesicles bump into things. Lysosomes lurk nearby with a slightly judgmental air, like they're waiting for someone to make a mistake they can clean up. You keep your distance. They look like they've seen things. Time doesn't move here the way you're used to. There are no clocks, no sky, no circadian rhythms. Only the slow pulse of cellular life. The endless looping motion of molecules being broken down, rebuilt, folded, packaged, and shipped. There's a soft rhythm to it all, like a heartbeat that never speeds up. Occasionally, a random molecule crashes into you, seemingly at full speed. You spin gently, disoriented, before settling again into the drift. No one apologizes. It's fine, you didn't expect manners. There's something oddly relaxing about it all. You don't have to think, you don't have to move with intention, you don't have to figure anything out, you're just part of it. One drifting piece in a crowded microscopic city that never fully wakes or sleeps. You're not cold, you're not scared, you're just small, soft, surrounded, suspended in a slow dance of chemistry and chance. Maybe you'll find out what kind of cell you are, maybe you won't. For now, you let yourself float. No pressure. Just drift. We've been drifting for a while now, not that time really applies here. There are no clocks inside a cell, no ticking seconds, no sunrise or sunset. Just a warm, slow soup of molecules swirling around you like sleepwalking commuters who all forgot their destination. By now you've accepted that you are a cell, or at least, something inside a cell. You don't remember applying for this position, and you certainly weren't trained for it. But here you are, suspended in the cytoplasm like a question that hasn't been answered. You begin to wonder, what exactly am I supposed to be doing here? It's a fair question. Everyone else around you seems to have a job. The ribosomes? Always building something, twitching, unfolding tiny chains of amino acids into neat little proteins, like origami experts who've had too much caffeine. The mitochondria? Still glowing with quiet arrogance, converting glucose into ATP, with the energy of someone who actually read the manual. Even the vesicles seem to be going somewhere, wobbling with purpose as they transport mysterious packages to who knows where. And then there's you. Floating. You try to look busy. Maybe if you hover near the endoplasmic reticulum, someone will assume you're assisting, but the ER doesn't acknowledge you. It just hums along, its folds rippling like an endless maze made entirely out of sleepy biological ribbon. You wonder, briefly, if you were supposed to be a white blood cell. That sounds important, protective, noble even, but you're not twitchy enough for that. White blood cells move with a kind of barely contained panic, like they've always just received terrible news. They rush from place to place, checking everything for danger, even perfectly innocent red blood cells, who frankly look exhausted from being interrogated. No, you're definitely not a white blood cell. Maybe you're a red blood cell? That has a nice ring to it, functional, streamlined, purposeful. But then again, red blood cells don't really hang out here. They travel through blood vessels, zipping along in single file, carrying oxygen like tiny biological delivery trucks. You haven't left the cytoplasm yet. And you haven't carried anything, unless you count mild existential confusion. So not that either. You spin slowly in place and look around. Or rather, you sense around. There's no real seeing here. No pupils, no corneas, no light. Just impressions, movement, soft pulses of energy, and chemical nudges that whisper in a language you haven't quite learned. You try to find someone who looks in charge, maybe the nucleus. It's over there, dense, round, quiet. The nucleus doesn't speak, not out loud. It just radiates importance. It sits at the center of everything like a manager who's not available for questions. You approach cautiously. There's a semi-permeable membrane guarding it, and you're not sure you're cleared for entry. A nearby RNA strand unspools itself lazily and drifts out of the nucleus, ignoring you completely. You take that as a sign. This may not be the place for answers. You drift backward, mildly embarrassed. Maybe your role isn't glamorous. Maybe you're just here to exist. Not everything has to be heroic. Maybe your background support, biological ambience, molecular wallpaper. You sigh, metaphorically of course. You don't have lungs, or a mouth, or much of a face really. Still, you take a kind of comfort in your not knowing. After all, no one seems to be checking up on you. There's no manager breathing down your neck. No mitochondria assigning tasks. You are unsupervised. Peacefully unqualified. Delightfully underdefined. You drift past a microtubule, long, thin and slightly tense, like a coworker with a too detailed spreadsheet. It twitches slightly as a vesicle glides along it, pulled by a little motor protein that actually walks, along the track with two tiny feet. You stare at this for a moment, baffled and weirdly impressed. The motor protein doesn't acknowledge you either. It's clearly busy. So far you've discovered that you're not very helpful. You don't have a clear job description. And you're pretty good at staying out of the way. That's something, right? There's a certain peace in purposelessness. No deadlines, no enzymes demanding reports, no pressure to be productive. You exist, and the cell seems perfectly fine with that. A small, folded protein drifts near you and offers no explanation for its shape or location. You admire its confidence. You roll slightly to one side, though directions are still vague, and bump into a lipid droplet. It's round, squishy, and unapologetically greasy. You both bounce off each other like two strangers on a crowded sidewalk who can't be bothered to say sorry. Still, no one's asked what you're doing here. Maybe that's the trick. Maybe being a cell isn't about knowing, maybe it's about being. Floating. Watching. Letting the rhythm of the cytoplasm carry you like a lazy river through a biology textbook. And so, you do. You float. Not knowing, not needing to. You close the non-existent eyes you don't have. And rest. After what feels like several eternities, and one very awkward brush with a rogue protein chain, you decide it's time to explore a little farther. You've stayed mostly in the inner goo of the cytoplasm up until now, letting it cradle you like a sleepy bathtub full of molecules that all have somewhere to be. But now some small nudge, maybe boredom, maybe osmosis, draws you outward, toward the edges, toward the membrane. Ah yes, the cell membrane, the mysterious, flexible gatekeeper that holds everything in place, while letting very specific things come and go. Like a nightclub bouncer, if the bouncer were made of lipids and had a PhD in selectivity. You drift toward it slowly. There's no rushing here. Every movement feels like it takes just a little more time than you expect. Which, oddly, is calming. The closer you get, the more complex it becomes. The membrane isn't just a boring outer wall. It's alive with motion. Not in a dramatic way, of course. Nothing here is ever in a hurry. But it shifts constantly. A shimmering mosaic of phospholipids. Fatty little molecules that arrange themselves in a double layer, like introverts at a group dinner. Heads facing out. Tails tucked safely inward, avoiding confrontation. Here's the thing about phospholipids. They're polite, self-organizing. They don't need a memo to line up correctly, they just do. You admire their quiet cooperation. Embedded in this wiggly, undulating sheet are proteins, some acting as gates, others as receptors. They sit there like cranky lifeguards, allowing only certain molecules through, while ignoring the rest. You watch one of them twitch slightly, as a small sodium ion tries to sneak past. The ion gets waved through with a kind of molecular shrug. Clearly, it's irregular. Another protein nearby is less forgiving. It blocks a curious glucose molecule with the steely determination of someone who's memorized the guest list. Not tonight, glucose. You press gently against the membrane. It gives a little, but doesn't break. There's something oddly reassuring about its resistance. It's not harsh, it's just firm, like the hand of a grandmother gently pushing you back from the cookie jar before dinner. You wonder what's beyond, outside the membrane. Technically, it's the extracellular space. But you're not sure what that means in a way that matters. You don't have much of a memory. There's no concept of before or after here. Just now. Just drift. Just membranes and mitochondria and ribosomes occasionally bumping into you like tired bees in a slow-motion hive. Still, you try peeking through one of the protein channels. You can almost sense the world outside. It's faint, barely there, but it feels colder, quieter, less gooey, less welcoming. You retreat. Back inside, the membrane closes behind you like a curtain in a very microscopic theater. No applause, no curtain call, just more slow drifting. You decide to follow along its edge for a while, skimming the boundary between in and out. There's a rhythm to it. The membrane undulates like soft breath. Not mechanical but biological. Peaceful, protective. Imperfect, but consistent. Nearby, a cholesterol molecule wiggles its way between the phospholipids, reinforcing the structure with all the smug stability of someone who shows up to every meeting 5 minutes early. You decide cholesterol is the type who always carries a clipboard, quietly competent, underappreciated. Further along the edge, you stumble across something odd. A signal protein is glowing faintly. It pulses once, then stops. You're not sure what it means, but the other molecules seem to care. A ripple of quiet chemical reaction passes through the area. Nothing explodes, no one panics, but something shifts. Maybe the cell is responding to something outside. Maybe it's just stretch marks of a body digesting dinner. Whatever it is, it passes. The glow dims, the signal fades, everyone resumes floating. You exhale, not really of course, you still don't have lungs, but emotionally, you release a sigh. You lean back, again figuratively, and watch as a vesicle merges with the membrane. It presses in gently, fuses, and opens to release its contents out into the unknown. You can't help but feel a little nervous for whatever just left. You hope it packed well. For a moment you wonder if that could be you someday, merging, leaving. But you're not ready for that kind of commitment. For now, you stay here, nestled against the inner wall of a living, breathing cell. Floating in a crowded sea of cooperative molecules and tiny, busy know-it-alls. There's something calming about being unimportant in such a precise and overachieving world. You're not in charge, you're not in trouble, you're just here. Floating. Drifting. Resting. And as the signals quiet, and the cytoplasm softens to an even slower rhythm, you let your imaginary eyelids droop once more. Because even cells deserve a moment of peace. You don't remember signing up for this. One moment you were drifting quietly through the cell, unbothered and unofficial. like someone who shows up to a workplace lunch without technically being on staff. And then, somewhere between a floating lysosome and a phospholipid traffic jam, you were recruited. It wasn't a conversation. No one asked. There was no interview. Just a mild pressure, a ripple of instruction from the nucleus, and a vague chemical message that, if translated into human terms, would probably say something like, "Congratulations. You're part of the immune system now, good luck." You don't know what that means. You barely know what you are, but suddenly you're not just floating anymore. Now you're drifting with intention. Sort of. You've been assigned a role in the immune response, the biological version of a neighborhood watch, except instead of nosy neighbors and suspicious backpacks, you're now on alert for pathogens, foreign proteins, and molecular bad guys. You'd be more excited if you weren't mildly terrified. The first thing you notice is that your surroundings are different. You're still in the body, sure, but the vibe has shifted. Things are tense here. The cells in this neighborhood move like they're caffeinated, fast, precise, alert. You spot your first white blood cell. It's big, amorphous, and oddly beautiful, like a living blob of concern. It flows more than it walks, squeezing through gaps, scanning everything it encounters like an overworked security guard with trust issues. It doesn't look at you, but you feel its presence. It seems to be doing 12 things at once. You suddenly feel underqualified. You try to mimic its movements, but you're slower, clumsier. You accidentally bump into a nearby B cell and quickly apologize, though you're not sure if it understood. The B cell is busy manufacturing antibodies, tiny Y-shaped proteins. It flings out like confetti at a very suspicious parade. You try to understand what's happening, but your biology textbook knowledge is limited. You overhear a dendritic cell whispering instructions to a T cell, and something clicks. This isn't just chaos, this is coordination. Each immune cell knows its role. Some are scouts, others are assassins, a few are glorified messengers. And then, somewhere in this weird cellular army, there's you. Phineas Wurdaken. You still don't know what your job is. No one's handed you a title, but it feels like the kind of situation where if you don't do something, you might get absorbed by a macrophage out of sheer confusion. You drift closer to the edge of a capillary, a blood vessel, narrow, bustling, full of red blood cells streaming by like determined commuters. Occasionally, a white blood cell squeezes between the vessel walls, a process called diapedesis, or, as you interpret it, molecular crowd-surfing with attitude. You hesitate at the edge, uncertain. Do you squeeze through? Are you supposed to? Before you can decide, a cytokine signal reaches you, a whispery nudge of biochemical suggestion. It says, "Infection nearby, mobilize." You are suddenly very aware that you may have to do something brave, or at least moderately useful. You pass by a neutrophil, who looks like it hasn't slept in years. It emits the quiet, buzzing intensity of a cell who knows exactly what bacteria look like, and doesn't trust anything. It doesn't stop to chat. You try to follow. You still don't know if you're fighting, observing, or just trying not to get eaten by your own side. A nearby natural killer cell floats by, humming with the casual menace of something that deletes infected cells without waiting for a second opinion. You give it plenty of space. Whatever your job is, it's probably less dramatic. Eventually you settle near a group of cells forming a barrier, creating a defensive line around a patch of inflamed tissue. It's warm here, not emotionally, literally. Inflammation is the body's version of turning up the thermostat when something seems wrong. You imagine the voice of the immune system going, "Everyone stay alert." And slightly sweaty. You're offered something. A receptor maybe. It clicks into place on your membrane with an oddly satisfying plop. Suddenly you feel more aware. Not smarter, necessarily, but attuned. Like someone turned the contrast up on the situation. There's no ceremony, no welcome party, no HR packet. But somehow you are now part of the immune system. You don't have a weapon, you don't have a map, but you have a place. And in the slow drifting quiet of the body's inner defense, that's enough for now. You drift, half-trained, barely briefed. Ready, or at least present. And somewhere far off, something foreign enters the bloodstream. You don't know it yet. But your role is about to matter. For now, you rest. Floating. Waiting. A small, possibly important piece of a very large, very sleepy puzzle. You are officially part of the immune system now. Still untrained, still confused. But technically employed. You haven't received a name badge. No one's explained your benefits package. But that doesn't seem to matter. Everyone else seems to just know what to do. So you follow along. The tissue around you feels tighter now. The cytoplasm slightly more crowded. And the signaling proteins a little more insistent. You hear them in a way that isn't quite sound. Like overhearing someone muttering from inside a sealed room. Fuzzy but urgent. Cytokines, chemokines, faint whispers of inflammation, calling cells like you to gather. You drift toward it, whatever it is. Ahead of you, a neutrophil glides past again, bruised-looking, focused, and probably too tired to explain anything. It oozes forward like a wet snowball that means business. You keep your distance. Further down the cellular corridor, you spot a macrophage. At least, you think it's a macrophage. It's massive, balloon-shaped, and very busy. It seems to be absorbing something, a bacterial fragment maybe, folding its massive membrane around it in a process called phagocytosis, which is science's fancy word for hugging something to death. You don't want to be hugged like that. So you steer wide. As you pass, the macrophage belches out a small, globby message, a chemical update, telling nearby immune cells what it just devoured. There's no emotion in it. Just the facts. A calm, clinical biological memo. Something like, pathogen fragment digested, all clear not confirmed, send backup. How reassuring. You wonder if this is how things always go, constant surveillance, constant microdramas. None of it loud or flashy. Just thousands of quiet molecular jobs being done by cells that no one ever thanks. You spot a T helper cell, giving instructions to a cluster of new arrivals. It gestures, if that's the word for it, with surface proteins that blink and bind and relay complex immunological strategies. To you it looks like a pile of blinking Christmas lights floating through molasses. But the other cells seem to get the idea. You wait patiently. Maybe someone will notice you and tell you what you are. Eventually, a dendritic cell drifts close. It's elegant. Like the tree of life was shrunk down and dipped in static electricity, branch-like extensions reach toward you, scanning your surface. It pauses. Something on your membrane catches its interest. You brace for impact, or orders, or digestion. But instead it just gives you a kind of biochemical shrug, a silent message transmitted through faint receptor signals. You're not dangerous. Probably. Try to stay out of the way. You nod, internally. That's honestly the most helpful guidance you've had all day. You continue floating, purpose adjacent. Then, without warning, you feel something tugging at you. Not physically, more like conceptually. as if a deeper part of the immune system has decided to assign you something specific. You don't resist, you couldn't even if you wanted to. You feel a shift on your membrane, a new protein locking into place, a marker, one that subtly but officially identifies you as part of the defense team. It's like being handed a security vest you can't remove. Congratulations, you've been flagged for a role. You are now what's known as an innate immune responder. The first line of defense. The one that gets called in before anyone even knows what's going on. Think of it like being on call without knowing your shift started. Your job isn't dramatic. You won't be destroying viruses or leading antibody production. But you will be watching, patrolling, reporting. You're the immune system's version of someone who walks slowly through a grocery store just to make sure no one's stealing apples. Still, there's dignity in it. You wander further, sensing small alerts in the environment. Chemical flags planted by cells under stress. There's no blood, no yelling. Just faint, flickering signs that something nearby isn't quite right. Maybe someone stubbed their cellular toe. Maybe it's an infection. Or maybe it's just the body digesting lunch too aggressively. You don't know, you don't need to. You just hover nearby and listen to the signals ripple through the tissue. And in your quiet drifting, you start to sense something deeper. A system beneath the system. Not the drama, not the digestion, but the rhythm of the body. The slow orchestration of cells responding, reacting, returning to baseline. You're part of that now. A tiny node in a massive network of trust, function, and quietly panicked efficiency. And for the first time that feels okay. You don't know everything. You still haven't figured out what a lymph node does. But you're here, you're contributing. You haven't been absorbed by a macrophage. And in this body, that's a pretty decent start. You drift back toward your home cell, a little more connected, a little less lost. Sleepier now. Whatever happens next, you'll handle it. Or someone else will. That's the thing about immune systems. They're built on shared responsibility and naps. By now you've fully accepted your role in the immune system. Not out of confidence, but more from a quiet cellular shrug of, well, this is happening, I guess. You've been marked, receptors placed, surface molecules updated. You are officially part of the innate immune response, though official is doing a lot of heavy lifting here. No one clapped. There was no welcome bag. Still, you patrol. Well, you float in loose circles near the capillary wall, blinking slowly and hoping no one asks you a question you can't answer. Which is every question. Things seem calm. You watch a few red blood cells zip by like commuters on a very punctual train. You nod politely at a passing eosinophil. You try to look busy. Then you feel it. It's not loud, not dramatic. But in the subtle language of cells, it's like a fire alarm made of whispers. A pathogen. Somewhere nearby, something foreign has entered the system. You don't know what kind. Bacteria, virus, mysterious microbe with too many legs? All you know is that suddenly, every cell around you is paying attention. The dendritic cells stiffen, figuratively, because they're mostly goo. The neutrophils increase speed, flowing like puddles of urgency toward the alert site. Even the macrophages begin to lumber toward action, their membranes rippling with righteous hunger. You panic a little. Not because you're afraid, but because you still haven't read the manual. You try to remember what you were supposed to do in this situation. Something about flagging antigens, releasing cytokines, being slightly useful. You search yourself literally for anything that might help. Ah, there it is. A tiny protein you can release, a chemical signal that says, yes, something's wrong, and I am acknowledging that loudly. You send it out. The biochemical equivalent of raising your hand in a meeting and saying, I agree with what was just said. It's not much, but it's something. A moment later, a wave of immune cells flood past you. Real responders, experienced ones. You spot a killer T-cell that looks like it's seen some things. It ignores you, which you're grateful for. You get the impression that if you tried to talk to it, it would just stare at you with 1,000-yard cytoplasmic glare. So instead, you hover. Still alert. Still vaguely helpful. The infection is small, thank goodness. Probably a minor breach. Maybe a few bacterial cells slipping through a minor gut lining crack. The real immune cells make short work of it. Macrophages engulf. T-cells deploy lethal molecules. B-cells begin preparing antibodies from afar. You monitor the edges. Like the world's most awkward usher at a show you didn't buy tickets for. And then, just as suddenly as it began, it's over. The chemical alarms die down. The inflammation fades. The swelling in the tissues recedes. Cells return to their normal, bustling lives. You exhale, or you would if you had lungs. A passing mast cell pats you on the metaphorical back with a quiet nudge of its membrane. It doesn't say anything, but the message is clear. You didn't mess it up, that's what matters. You beam with internal pride, you did your part. You signaled, you stayed alert, you didn't drift into a mitochondrion and get recycled by mistake. Sure, no one's giving you a ribbon. But in this microscopic world, competency is celebration. You make your way back to quieter tissue, the kind with soft fluids and fewer chemical pings. You settle near a gentle flow of lymph, where the signaling molecules are lazy and the immune pressure is low. You've earned this. Even if all you did was quietly not make things worse. As you drift into this new, calmer pocket of the body, you finally let go of the tension. No job is ever really done in here, but sometimes you get a break. And in the warm, floating stillness of the interstitial fluid, you almost feel proud. You may not have picked this job. You may not fully understand it. But you're doing it. And tonight that's enough. You close your non-existent eyes and let the body do its thing. For now, your shift is over. You've been floating for a while now. Resting. Drifting. Trying not to bump into anything too important. And for a moment there, you were starting to believe you had some space to yourself. Just you and the soft, lapping cytoplasmic tide. But now, the crowd is arriving. Cells. So many cells. You had no idea the human body was this densely populated. You'd pictured it being mostly empty space, like a dimly lit library with occasional quiet murmurs. But no. This is a marketplace on a Saturday, a crowded elevator, a family reunion you didn't RSVP for. They're everywhere. Red blood cells swirl in endless torrents, disc-shaped and directionless, like bumper cars that gave up trying to avoid each other. White blood cells move with purpose, each one radiating some combination of focus, fatigue, and quiet resentment for being overworked. Platelets dart past in twitchy swarms, like glittery little anxiety particles. You attempt to float through this biological bustle with as much grace as a new cell can muster. But you are jostled, repeatedly. At one point, a lymphocyte bumps you from behind and doesn't even apologize. Which is probably fair because you're not entirely sure you're going the right direction anyway. There are membranes everywhere, rippling, brushing, merging, releasing signals. Some cells blink softly with surface markers, others pulse with chemical messages. There's no shouting, no talking, and yet, it is deafening in its own way. 1,000 tiny exchanges happening all at once. Antigen presentations, enzyme releases, nutrient swaps. You pass by what looks like a fat cell, glossy and full and shockingly relaxed. It's just there, not moving. Storing energy, vibing. You envy it briefly. Then, you're nearly sideswiped by a microglial cell, clearly busy, probably on its way to investigate something suspicious near the brainstem. It gives you a curt surface protein flick, the molecular equivalent of "watch where you're going." Sorry. You navigate toward a quieter tissue pocket, hoping for a little elbow room, even if you don't technically have elbows. But even here, it's not exactly serene. It's just a different kind of crowded. The gut lining, you learn, is basically the Times Square of the body. Billions of bacteria, friendly ones, mostly, but still, not exactly introvert-friendly. You peer into the gut microbiome and feel immediately overwhelmed. It's a chaotic party you weren't invited to, and frankly, wouldn't attend even if you were. The bacteria are loud in their own way, buzzing with genetic chatter and fermenting things no one asked them to. Enzymes splash about. Sugars are split. Gases burble ominously. You retreat quickly. Eventually you make your way toward a place with slightly fewer bodies per microliter, the interstitial space. It's still busy, but the pace is slower. Cells seem less frantic here. It's the difference between morning rush hour and the sleepy afternoon lull. You finally find a small crevice between two fibroblasts and wedge yourself in. It's not private, but it's quiet. You watch the others pass by. Some are old, wrinkled in their own microscopic way, their membranes worn, their pace slower. Some are young, shiny, enthusiastic, a little too bouncy. You realize that the body is not a static place. It's more like a city with no downtime. Construction, repair, breakdown, patrol, all happening in the same square micrometer. You are part of that now. One microscopic citizen in a metropolis that never sleeps. And despite the crowd, despite the noise, there's a strange comfort in that. Because no one here is truly alone. Not even a confused little immune cell who didn't know what a cytokine was last week. You nestle deeper into your space between the cells. The gentle hum of cellular life washing over you like soft static. You don't need silence. You just need not to be needed for a moment. And here, in this slow-moving, overly populated world, you finally find rest. By now you've learned one unshakable truth. You are not alone. Not even a little. Not even for a second. The human body is, quite frankly, teeming. A cellular metropolis so densely packed it makes rush hour on a rainy Monday feel like a casual stroll. And unlike most cities, you can't just keep your head down and walk fast. Because here, everyone is rubbing shoulders. Or membranes. Or cilia, in some cases. Personal space is not a concept, it's a dream. A rumor passed down by older cells with exaggerated stories. You start trying to make sense of who's who in this biological traffic jam. Because while everyone looks vaguely blobby to you, they're definitely not all the same. Over there, those shimmering red discs? red blood cells. The oxygen couriers. They move in endless loops, barely noticing anything outside their hemoglobin agenda. They don't talk, they don't slow down. But they're oddly majestic in their purpose. Always delivering, never asking questions. And here are the dramatic ones. Mast cells. You can smell the histamines from here. One moment they're fine, and the next, boom, full allergic meltdown over a dust particle. They live on the edge, those ones. A sneeze away from overreaction at all times. You pass a macrophage, slow and thoughtful. Big. Squishy. Wise in a way only old immune cells are. It glances at you, then continues digesting something that looks like it used to be dangerous. You want to ask it a question, something existential. But you get the feeling it's in the middle of a very long chew and doesn't want to be disturbed. Then there's the T-cell crowd, a bit intense. They walk fast, talk fast, and carry more enzymes than seems necessary. They're the soldiers. Patrolling the bloodstream like undercover agents at a party. Always looking for something wrong. Always ready to shout intruder and start the molecular equivalent of a bar fight. But not all cells are loud. You find a pocket near the neurons, strange elongated cells that send electric whispers across vast stretches of the body. They don't float like you do. They're rooted. Locked into place like ivy along the walls of a quiet cathedral. But their messages are constant. Flickers of electrical energy. Neurotransmitters hopping from synapse to synapse like gossip on a particularly juicy Tuesday. You admire them from a distance. You get the sense they're important. And busy. And far too tired to explain anything to a molecule like you. You drift along a bit more and find yourself passing the liver, or at least part of it. Here, the hepatocytes are humming along with near-mechanical efficiency. Processing toxins, storing nutrients, making cholesterol whether anyone asked for it or not. You watch one wrap up a molecule of alcohol like it's taking out the trash. It sighs. You relate. Further along the way, a cluster of stem cells dozes quietly in a niche. They're not in a rush. They don't even know what they're going to be yet. The ultimate overachievers in waiting. You wonder what it's like to have that much potential and absolutely no pressure. Then you remember you have an immune job and no clue what you're doing. You try not to spiral. Eventually you find a quieter path and settle in beside a sleepy glial cell. Neither of you says anything, mostly because you can't. But there's a quiet camaraderie in your shared inactivity. It watches a neuron flicker. You pretend you understand what that means. In time, the buzz of the cell city begins to fade. You don't stop moving, but you stop thinking about how crowded it is. It's just the way things are. Everyone moving in microscopic choreography. Each with their task. Their cycle. Their signal to send or receive. And you're learning to read it all. Not fluently, not yet. But you're starting to understand the rhythm. The gentle, pulsing flow of function and form. You press in just slightly, settling again into the steady hum of bodies around you. There is no silence in here. But somehow, it's deeply quiet. Everything seems to be going relatively well. You've figured out how to float without crashing. You've learned not to make eye contact, figuratively, with the overzealous white blood cells. You've even stopped panicking when a platelet brushes too close. In the grand scheme of being a newly conscious cell inside the human body, you're holding it together. And that's when the trouble begins. It starts as a murmur. Not a sound, exactly, more like a subtle shift in the cytoplasmic wind. A change in chemical scent. Something that makes the older cells stand a little stiffer. The macrophages look twitchy. A few neutrophils begin whispering in protein pulses. A T-cell somewhere mutters something dramatic and sprints off like it's got somewhere very inflammatory to be. You tilt your membrane in confusion. Then you see it. Something small. Foreign. Floating in like it owns the place. A bacterium. Alone, for now. And lost, perhaps. But unmistakably not supposed to be here. It looks different. Its outer membrane has none of the polite receptor markers. Its proteins are suspiciously loud. It looks different. Its outer membrane has none of the polite receptor markers. Its proteins are suspiciously loud. And it's wobbling with a kind of chaotic energy you haven't seen before. You blink, figuratively. Is this normal? Apparently not. Before you can float away or politely mind your own business, a nearby macrophage lurches forward. It's not a fast movement, but it is deliberate. Like a grandma preparing to scold a particularly disrespectful dinner guest. The bacterium twitches, sees the lumbering immune cell, and starts to backpedal. But it's too late. The macrophage engulfs it. Whole. In one slow, firm, professional gulp. Then it sits there, digesting it with the quiet pride of a librarian who just removed a disruptive teenager from the reading room. Everyone pretends not to look. But you all saw it. The immune system doesn't play. You drift nervously. That could have been you. Not the bacterium exactly, but someone who looked out of place, said the wrong thing, floated into the wrong chamber at the wrong time. It's not personal. It's just protocol. As the macrophage begins releasing little chemical puffs to alert the others, the entire cellular community shifts its mood. The gentle buzz of the body's crowd sharpens into something purposeful. This isn't chaos. Oh no. It's coordination. Like watching an entire ant colony suddenly switch into storm prep mode. Cytokines, chemokines, histamines. You don't know what half of them mean, but they're flying past like urgent memos in an office with no coffee. The T-cells return, now in full drama mode. They swarm in, demanding antigen IDs, scanning protein surfaces like bouncers at an immune nightclub. You attempt to look inconspicuous, which is hard when you're literally glowing faintly with confusion. Don't panic, you whisper to yourself. You're part of the body, probably. A dendritic cell strolls past you, slow, wide, unfazed. Its surface bristles with pieces of what you assume are the bacterial intruder, like it's wearing the thing as a warning sign. You have no idea how it's not completely overwhelmed. Then again, dendritic cells seem like the sort who have very complicated coffee orders and still show up calm to meetings. As the immune response winds down, at least for now, you feel the collective tension ease. The chemical air clears. The enzymes simmer down. And the cytoplasmic current starts to return to its usual sluggish swirl. You've just witnessed a miniature war. Over in minutes. Quiet. Efficient. No explosions, no speeches. Just silent defenders and a lot of very serious membrane flicking. You tuck yourself into the fold of a quiet epithelial wall and let the moment settle. For the first time you realize this place isn't just busy. It's alive in every sense. It defends itself, it adapts. It makes decisions without asking for permission. And you? You're a part of it. Somewhere between soldier and bystander. Floating with a purpose you don't fully understand yet, but it's there. The city never sleeps. Not really. But it does have quiet corners. And right now, you're in one. Wrapped in the soft buzz of post-chaos calm, you settle again into stillness. No alarms, no antibodies, no one shouting about enzymes. Just the distant murmur of metabolism, and the gentle thought, you made it through the day without getting digested. Not bad, for a cell. You start noticing it slowly. A kind of chemical yearning. Not hunger exactly. Not like, ooh, I could go for a warm bowl of something cozy. More like a faint alarm clock inside your cytoplasm ringing with purpose. Something's missing. Your molecules are grumbling. Enzymes are pacing. Your mitochondria are side-eyeing you like, hey, you gonna do something about this, or should we just burn muscle tissue for fun? You try to reason with your surroundings. You are, after all, a respectable cell. You would never barge into someone else's vesicle and start digesting without permission. But here's the thing about being a cell. You don't really get to order lunch. You are lunch. Sort of. Because the moment nutrients arrive, it's not because you found them. It's because something bigger than you, something human, decided to eat. A sandwich, a salad, maybe 3 bites of something half-hearted because they were too busy for lunch. Whatever it was, you're stuck with the results. And now that those nutrients are drifting down the bloodstream, the real fun begins. First come the carbohydrates. Sugars mostly. They arrive wide-eyed and a little sticky, like kids on a field trip. You wave one down with a membrane transporter, politely. It oozes in. And just like that, you're in the energy business. Welcome, your mitochondria seem to say, we'll be breaking you down now. Then the amino acids come next, smaller than proteins but sassier. They're not here to be broken. They're here to build. To become part of something. Muscle, maybe, or enzymes. They haven't decided yet. You shuffle some of them to the endoplasmic reticulum, a cellular conveyor belt if there ever was one. Tiny ribosomes sit like factory workers on a night shift, assembling protein after protein with no break in sight. It's beautiful. And loud. And slightly chaotic if you're being honest. Meanwhile, the fats are fashionably late. They float in slowly, dressed like they think they own the place. You accept them anyway, because even a self-respecting cell knows when it's time to build a membrane, or store some backup calories. You're learning the rules. You don't get to pick the menu. But you do get to host the party. And hosting is exhausting. As the nutrients roll in and your organelles work overtime, you begin to notice a new rhythm. Everything inside you is timed. Measured. Calibrated. Glucose becomes ATP. ATP becomes action. Proteins get folded. Waste gets sent packing. You don't sleep, exactly. Cells don't nap. But there is rest in rhythm. In knowing what comes next. In doing the same thing over and over. With just enough variation to make you feel like maybe you're getting the hang of it. You have your own little purpose now. And it might not seem glamorous, but it matters. You power the system. You build the body. You respond to the needs that trickle down from the unknowable choices of the human who contains you. You don't have thoughts. Not the way you used to. Not words or wants. But you have direction, function, and something about that is deeply calming. Even as the sugars slow down, and the proteins quiet, and the enzymes stretch their metaphorical limbs in post-digestion peace, you remain present. Content, for now. Full. In every sense of the word. Digestion, it turns out, is not just a personal experience. It's an industrial event. And you're not just floating around being fed. You're running a full-time, no-vacation, bio-powered tiny factory from the inside. You begin to understand this around mid-shift. Just as the initial rush of glucose tapers off, and the first batches of proteins finish folding. There's a lull. A pause in the chaos. And then another wave arrives. A new shipment of amino acids, vitamins, trace minerals, stray iron ions, and even a few mystery molecules still wearing the chemical equivalent of a "Hello, my name is" badge. They don't know where they're supposed to go. Neither do you. But it doesn't matter. Because the system kicks in anyway. The Golgi apparatus, once a mild-mannered stack of membranous pancakes in the corner, suddenly becomes the overworked mailroom of your entire operation. Sorting, tagging, shipping. Every protein it touches is packaged up and sent somewhere. Out to the bloodstream, over to another organelle, or tucked gently into storage like a keepsake for a rainy metabolic day. And you coordinate. Not consciously, not exactly. But with an innate, miraculous choreography. It's like being inside a machine that builds itself while it's running. And you're both the parts and the operator. Don't think too hard about it. It's working. Somehow. You catch yourself marveling at the ribosomes again. Still assembling, still churning out tiny chains of amino acids like they're late for a protein convention. No eye contact, no breaks, just relentless folding and bonding. You wonder how they know when to stop. Then again, so do you. Energy starts to dip. ATP levels sink. The mitochondria, loyal as ever, burn through what's left of the glucose, with a kind of silent, flameless efficiency. They're like the introverts of the organelle world, quiet, intense, and absolutely essential. A couple rogue lysosomes rumble by, dragging cellular garbage toward the waste chute, like sleepy janitors on night shift. They pause briefly to glare at a misfolded protein, then engulf it with a wet squelch and move on. You try not to take it personally. Somewhere in the distance, maybe near the nucleus, you catch a signal. A chemical one. Small, precise. It's not a message to you per se, but it's meant for someone in your department. Maybe an instruction. Maybe a warning. Either way, you comply. You don't really question signals. You don't have the luxury of rebellion. But oddly, there's comfort in that. You don't have to choose what matters. It's decided for you. And all you have to do is keep operating the little machinery, nudging molecules here and there, maintaining your inner balance. You feel not tired exactly, but aware of your own limits. Like a coffee shop at closing time, lights dimming slowly, one last cup in the drip tray. Even cells need a moment to breathe. Not real breaths, of course, You're anaerobic sometimes. But you get the idea. So you find a spot. Some soft pocket of cytoplasm. Close enough to the action to stay useful, but far enough to avoid another panicked amino acid delivery. And you float. Calm. Used. Needed. The factory doesn't stop. But it does settle. Like the hum of a city at night. Still working, always working. Just quieter now. Even in a body as well-oiled and biochemically brilliant as the one you now inhabit, some things just don't break down. Not neatly, not fully. Not ever. And that's how you learn about cellular disappointment. It begins innocently enough. A nutrient arrives. Or maybe a piece of molecular junk. You try to welcome it. You do your best, open your membrane channels, activate a few enzymes, bring in a lysosome or two. And then you wait. But it doesn't budge. Doesn't break. Just sits there. Awkwardly. Sometimes it's something exotic, like a foreign lipid that doesn't speak the local enzymatic dialect. Other times it's just a badly folded protein, a chemical origami disaster that nobody wants to claim. You pass it around your organelles like it's a microwave lunch that exploded and no one wants to clean up. The lysosomes glare at it. The proteasomes shrug. Even the peroxisomes, those little metabolic neat freaks, throw up their metaphorical hands. Eventually you do the only thing you can. You wall it off. Tuck it into a vesicle, zip it up tight, and shove it into a quiet corner of your cytoplasm. You name that corner. Later. Spoiler, later never comes. Welcome to the emotional clutter of cellular life. Now, this isn't unusual. Even human beings have junk drawers. Old receipts, expired soy sauce packets, and a mysterious tangle of rubber bands. You, as a cell, are no different. Some call it cellular aging. Some call it trash accumulation. You call it, look, I'm doing my best. But this raises a quiet question, one you feel stirring somewhere deep in your nucleoplasm. What happens when too much gets stored away? There's no alarm for this. No sirens. Just sluggishness. A delay in your reaction time. A slight stickiness in your chemical routines. Tiny moments when a signal doesn't arrive fast enough, or a ribosome hesitates just a fraction too long. You're still functional. Still part of the great biochemical orchestra. But now and then you wonder, how long can a cell carry things it can't digest? You let the thought float for a while. You're not afraid of it. Not yet. Instead, you busy yourself with what can be done. You clean. You recycle. You send waste toward the extracellular exit, little blebs of byproduct drifting toward whatever mysterious excretory fate awaits them. You patch your membrane. You boost a flagging mitochondrion. You listen for signals. You stay useful. Because even when you're harboring the cellular equivalent of an unflushable thought, you still have work to do. And strangely, that's enough. Outside your wall the body stirs. A faint twitch. A distant heartbeat. A reminder that this world is always in motion. You turn away from the junk vesicle and resume your slow, steady float. The factory isn't perfect. But it's still running. And so are you. You were just trying to mind your own molecular business. Floating peacefully. Digesting things semi-competently. maintaining the delicate work-life balance of energy production and existential confusion. But then something changed. The chemical environment shifted. Sodium levels ticked upward. Membrane potential got jumpy. Suddenly, everything around you feels more alert, more tense, more guarded. And that's when you remember the barrier. The sacred, semi-permeable, occasionally dramatic cell membrane. Your first home. Your last defense. And if you're being honest, an emotionally unreliable roommate. It's always doing something. Opening, closing. Responding to things you don't even understand. Stretching for no reason. Letting some ions in while dramatically rejecting others like a bouncer with very specific taste. It's not personal. It's just selective permeability. But right now, something's up. You drift closer and press your awareness against the membrane from the inside. It's crowded with protein channels. Some are whirring, some are twitching, and one especially overcaffeinated sodium-potassium pump is frantically swapping ions like it's running a black market. You ask, gently, what the issue is. A membrane receptor waves a protein arm vaguely toward the outside and mumbles. Foreign signal, might be nothing, might be something, we're treating it like a maybe. That's unhelpful. You wait. And then it happens. A ripple across the membrane. A cascade of signals. Suddenly you're flooded with neurotransmitter molecules. They're loud, excitable, and, if you're being honest, slightly chaotic. Every calcium channel in your vicinity pops open like popcorn. Ions rush in like concertgoers at a general admission gate. This, you realize, is not a casual update. This is a call to action. But, action where? And what exactly are you supposed to do? You're not a neuron. You're not even an immune cell. You're just you. A functional, possibly overlooked cell who happens to live next to a hyperactive synaptic zone. You wait for further instructions. None arrive. Just more molecules screaming, something is happening, without explaining what. So you do what any sensible cell would do in a high-stress, low-context situation. You stabilize your membrane. You patch any rips. You update your proteins and pretend everything is fine. Because sometimes, being a cell is less about understanding the body's grand design, and more about nodding politely while calcium ions throw a party in your foyer. You notice a leukocyte roll past in the bloodstream, scanning the area like an immune patrol. It gives you a long, slow look. You try to look uninfected. It rolls on. Eventually the chemical storm passes. The neurotransmitters get reabsorbed. The ion channels settle. The membrane stops vibrating with anxiety. And you? You resume floating. Your job hasn't changed. But now you're aware, acutely, that the barrier isn't just a wall. It's a front line. And you live right behind it. You once believed, naively, that the cell membrane operated like a logical gate. That it opened and closed based on rules. Chemistry. Structure. Predictability. But now, after what can only be described as an unannounced biochemical rave at your front door, you understand the truth. Cellular border security runs on vibes. Sure, there are rules. Channels open for potassium. Not sodium. Except sometimes. Unless calcium's involved. Or there's an emergency. Or the membrane just feels like it. You're beginning to think the entire system is based on hunches and peer pressure. There's that one chloride gate that always seems nervous. It opens too early, closes too late, and absolutely panics when it sees a neurotransmitter. You'd reassure it, but you don't speak ion channel. Then there are the receptors, those overly dramatic protein structures embedded in the lipid bilayer like antennae made of pure opinion. They light up the moment anything touches them. A hormone? Start the cascade. A growth factor? Panic and divide. A random bump from a neighboring cell? Well, let's just signal the nucleus just in case. You once watched a receptor trigger a full metabolic response because a molecule with slightly the wrong shape brushed past it. Better safe than dead, it muttered, as if that explained everything. You stopped asking questions. Instead, you stay back and observe. From your cozy place just beneath the membrane, somewhere between the actin scaffolding and the cytoplasmic end of a signaling pathway, you watch the front lines shimmer. Lipid rafts float like lifeboats. Membrane proteins shift subtly, constantly recalibrating. Every molecule that approaches is examined, judged, and either welcomed in or quietly ignored. And when the barrier really doesn't like something, it deploys endocytosis. Which sounds fancy but is basically just the membrane saying, I don't know what this is, but I'm swallowing it and dealing with the consequences later. Watching it happen is equal parts graceful and horrifying. The membrane folds inward, hugs the target like an overly affectionate aunt, and seals it into a bubble. Then it just drops it into the cytoplasm. You swear you saw a nearby organelle whisper, "Not it," before scooting away. You ask the Golgi apparatus if this is normal. It just sighs and prints more shipping labels. And the thing is, you get it. The body is messy. The extracellular space is chaotic. The immune system is dramatic. Sometimes you just have to bring things inside, poke at them a bit, and hope they're not contagious. That's biology. It's less symphony of life and more improv jazz in a crowded cafe. Confusing, unexpected, a little clumsy, but somehow still working. So you keep floating. Keep adjusting. Keep listening to the membrane's moods. Because you've learned one important truth. In here, it's not about being in control. It's about responding gracefully to the absurdity of existing. And if that means riding the whims of a semi-permeable border with a protein complex that can't make up its mind, so be it. It was bound to happen eventually. You knew this. You sensed it. You just didn't expect it to be today. You're going about your routine, monitoring the mood swings of membrane proteins, reorganizing your cytoskeleton just for fun, metabolizing a light snack when it happens. The barrier fails. Not entirely. Not dramatically. But just enough. 1 second. The membrane is bouncing around molecules like a bouncer with a clipboard. The next, it lets in something weird. It doesn't have a familiar chemical signature. It doesn't behave like glucose. It doesn't even try to disguise itself as friendly. It just strolls in like it owns the place. You freeze. Cytoplasm tightens. The nearby mitochondria dim slightly, like they're trying not to be noticed. You ping the nucleus. It sends back a single protein. Grimace. Not helpful. The thing that came in? It's small, but determined. A viral particle, maybe. Or a rogue toxin. Hard to tell, It's moving fast and leaking strange signals. You send out a distress molecule. Technically, a cytokine. It flares like a chemical flare gun. Help! Somewhere beyond the membrane, a white blood cell perks up. But inside, it's just you. And it. And a rising level of ATP-consuming panic. You try to contain it. Form a vesicle. Wrap it up. Smother it with enzymes. You even ask the lysosome nicely. The lysosome gives you a long look and says, "Sweetheart, I digest waste, not nightmares." Fair enough. So you improvise. You tag it with a ubiquitin marker. That's biology speak for someone deal with this. You push it toward the proteasome, like an awkward guest at a party you're trying to introduce to someone else so they'll leave you alone. But the proteasome shrugs. This one's above my pay grade. You're on your own. It tries to fuse with your DNA. You shove it back with a microtubule. It releases some sort of signal. You release adrenaline? Wait, no, you don't make that. You release frantic enzyme activity. Close enough. Eventually, after enough frantic signaling, stress protein expression, and dramatic intracellular rearranging, help arrives. A killer T-cell drifts by, checks your distress signal, and sends a message up the chain. You're flagged for possible viral infiltration, which is both terrifying and weirdly validating. Moments later, antibodies start flooding the area. There's a flurry of complement proteins. And just like that, the invader is gone. You're left blinking, exhausted and slightly traumatized. You check your membrane. Scuffed. But intact. Your organelles. Still mostly in the right places. The cytosol is quieter now. The signaling pathways dim. You float. Recover. Try to metabolize your feelings. And you realize something else. You survived. Maybe not gracefully. Maybe not heroically. But you stayed intact. And in this microscopic madhouse, that's a win. As you slowly drift toward rest, you can almost hear the membrane murmur. Well, that was something. Yes. Yes, it was. You've had some strange encounters in this cellular life of yours. Wayward viruses. Overcaffeinated receptors. Dramatic immune cells. But none compare to the relationship you now find yourself in, with a roommate you never chose. The mitochondrion. It didn't start here. It wasn't born inside you. In fact, a long time ago, back when cells were just lonely blobs paddling around primordial puddles, it was a total outsider. A bacterium. A squatter. An opportunist with a slick set of enzymes. But now? Now it lives inside you. And not just one. You're sharing your cytoplasm with dozens of them. Sometimes hundreds. And they do not pay rent. They lounge around the cytosol, folded membranes and all, churning out ATP like little molecular espresso machines. They're smug about it too. Every time you need energy, there they are, smirking, bubbling, flexing their Krebs cycles. You once tried to ignore them. Pretend you could get by with glycolysis alone. Big mistake. Turns out, without mitochondria you'd barely power a flagellum. So now you just coexist. You provide the glucose. They turn it into ATP. And in return they constantly remind you they used to be independent. You ask one, casually, what it's doing. I'm oxidizing pyruvate, it says with a yawn. Ever heard of the electron transport chain? I invented that. Charming. Also, slightly threatening. Because while they help you live, they also hold power. Too much power. They control your energy. They can trigger apoptosis, cellular self-destruction, if they feel like things are getting too dramatic. They're like live-in chefs who also have access to the launch codes. But weirdly, you kind of like them. There's something comforting about the hum of their inner membranes. Something familiar in the way they float beside you, always slightly warm, slightly smug, and undeniably necessary. And when you're stressed, like really stressed, they even adjust. They produce more ATP. They split into more mitochondria. They whisper protein-based encouragement from the inside out. It's codependent. But kind of sweet. Every now and then, one of them splits in two. Just like that, bam, now you've got one more little power plant in the family. No paperwork. No conversation. Just fission and float. You're not sure what the boundaries are in this relationship. And honestly, neither is biology. But in the end, you share this space. This squishy, complicated, membrane-wrapped life. And no matter how weird the past was, or how smug their enzymes are now, they've got your back. Well, your ATP. Same difference. If the mitochondria are the smug in-laws who moved in and never left, then the ribosomes are the caffeinated roommates who do all the cooking. Loudly. All the time. Whether you ask them to or not. They don't wait for permission. They wait for messenger RNA. And the second it arrives, hot off the nuclear presses, they pounce. You barely finish reading the transcript before one of them's already halfway through translating it. Clacking together amino acids like a chef throwing noodles into a pan. Fast, clumsy, and somehow weirdly graceful. And they are everywhere. Some float freely in the cytoplasm like little protein-hungry satellites. Others are glued to the rough endoplasmic reticulum, making it look like a shag carpet made of ambition. You once tried to count them. You gave up at several thousand. One of them waved. Ribosomes have exactly zero chill. Where mitochondria hum and meditate and sigh about oxygen, ribosomes are always halfway through yelling start codon with a mouthful of polypeptide chain. It's impressive. And chaotic. You watch as they assemble entire proteins from nothing but chemical instructions and pure audacity. One codon at a time. AUG, UUU, GGC, stop. Ding! New protein. Next? They don't even pause to celebrate. No applause. No good job, team. Just immediately onto the next mRNA strand. Some days, the nucleus sends out messages so fast, it feels like a protein pop-up shop inside your cytoplasm. Ribosomes pop up. Fold something. Fall apart. Pop up again. You ask one how it's feeling. It shouts back, busy! Then tosses you a peptide chain, and skids off toward a fresh bit of genetic code. You admire their work ethic. Even if it's a bit intense. Still, they're loyal. They show up every time. They don't judge your endoplasmic reticulum. They don't complain when the mRNA is weirdly folded or slightly garbled. They just build. Always building. Fast, focused, and fully committed to the hustle. And honestly, you respect that, even if the noise makes it impossible to hear your own cytosolic thoughts. You've met mitochondria, the smug powerhouses. You've endured ribosomes, the rowdy construction crew. But nothing prepares you for living under the watchful eye of the nucleus. The nucleus doesn't just think it's important. It knows it is. It carries itself like a CEO with no open-door policy. A head librarian who also writes all the books. A royal figure in a kingdom made entirely of molecules and mild tension. It sits at the center of everything. Swaddled in a double membrane. Sprinkled with nuclear pores like little security checkpoints. You can't just walk in. You have to be invited. And by invited we mean escorted, tagged and verified by a full escort of transport proteins. You once tried to sneak a transcription factor in, without proper labeling. Let's just say you got a sternly folded reprimand from the nuclear envelope. Inside, the nucleus is all chromatin and business. DNA coiled up like ancient scrolls. Histones dressed like bureaucrats. RNA polymerase zipping around muttering, "I'm already late for transcription." It's quiet in there, but in a way that feels important. Like the silence in a courtroom. Or a vault. You always get the sense that the nucleus is listening. Judging. Planning. And maybe a little tired of everyone's nonsense. Especially yours. You try to make a polite observation. "Hey, thanks for the genes." The nucleus blinks once, slowly, then sends out 16 strands of mRNA in response. You take that as a "you're welcome," but you're not entirely sure. To its credit, the nucleus does handle a lot. It's constantly managing data, dispatching genetic instructions, and regulating pretty much everything you are and do. Without it, you'd be a squishy puddle of aimless organelles floating in cytosolic confusion. With it, you're, well, still a bit confused. But at least you're organized about it. Sometimes you wonder if the nucleus ever wants to take a break. To just uncoil the DNA and chill. But no. It never rests. It delegates. It oversees. It quietly edits your entire molecular existence from behind its double-membraned office door. You sigh and float a little closer. Do you want a protein, you offer? The nucleus doesn't respond. It just issues another set of instructions. In triplets. Of course it does. If you thought being a cell meant peace, quiet, and the occasional metabolic reaction, you were mistaken. Because in here, in this microscopic metropolis, everyone's talking. All the time. About everything. Welcome to your new reality. Cell signaling. It starts small. A signal molecule bumps into your surface. Maybe a hormone, maybe a neurotransmitter, maybe a confused protein just trying its best. You try to ignore it. You're busy arranging your cytoskeleton and pretending to understand lipid rafts. But no. The receptor on your membrane lights up like someone pressed the doorbell twice. And now? Now you're in it. Inside, a cascade begins. You didn't ask for it. You didn't plan for it. But your cytoplasm has suddenly turned into a molecular relay race. One protein hands off a phosphate group to the next. That one slaps another into activation. And before you can say second messenger, You've triggered 6 pathways, 2 transcription factors, and a mild identity crisis. You try to backtrack. Maybe calm it down. Send a feedback inhibitor. Whisper, maybe let's not overreact to your endoplasmic reticulum. But it's too late. The Golgi apparatus is now rerouting traffic. The ribosomes are preparing for war. Calcium ions are bouncing off the walls like caffeinated toddlers at a sugar convention. And your poor nucleus? Trying to nap. But now it's getting flooded with requests. Should we divide? Should we produce more enzymes? Do we still like insulin? And in the midst of this intracellular chaos, one tiny molecule floats by and mutters, "Just checking in to see if you're okay." You're not. You're being chemically micromanaged from all directions. External signals, internal signals, feedback loops, checkpoint pathways. It's like every part of you wants to be heard, obeyed, and dramatically acknowledged. You consider playing dead. Just curling up and letting your ion channels handle it. But instead, you ride it out. You fine-tune the messages. You modulate the kinase activity. You gently suppress the transcriptional drama. And you emerge, just slightly frayed, but intact. At least for now. Because somewhere you know. Another ligand is waiting. Another signal is circling. And another receptor is one bump away from ruining your entire cytoplasmic afternoon. But for now, you float in a moment of silence. A very, very brief silence. And exhale, cytosol. You're minding your own cytoplasmic business. Tidying up a few proteins. Checking your mitochondria for smugness. Trying not to get involved in another intracellular dispute. And then it arrives. Floating in like it owns the place. A hormone. You can tell immediately. It's the way it carries itself. The way it glides past your membrane with an air of casual authority. As if to say, I don't knock, I get absorbed. And of course it's got the proper credentials. Lipophilic or hydrophilic, doesn't matter. If it's steroid-based, it's already halfway to your nucleus, slipping through the bilayer like it's made of privilege and confidence. Others prefer to shout instructions from the surface. Peptide hormones. Protein hormones. Signal-screaming divas who don't bother entering the cell. Because why would they? They've got receptors to do the heavy lifting. And the moment those receptors lock on, your inner life becomes very dramatic. Cascades. Second messengers. Protein kinases doing interpretive dance all over your cytoplasm. One little visit from a hormone, and suddenly you're turning genes on and off, altering your metabolism, and producing proteins you didn't even know you had the blueprints for. You ask politely, "Do you mind if I finish this glycolysis?" The hormone stares. "Not unless it involves growth, stress response, or reproductive function. Now be useful." You sigh. And comply. Because hormones are bossy. And powerful. And unfortunately, often right. Insulin? Keeps the glucose drama in check. Adrenaline. Wakes you up faster than any mitochondria ever could. Cortisol? Keeps a running tally of your stress, like it's your therapist with a clipboard. And the worst part? They don't even stick around. They deliver the message. Set off an entire protein opera inside you. And then just leave. off to boss around another cell, probably a liver cell, or a muscle fiber, or, heaven forbid, a neuron. But you can't deny their efficiency. They're like biochemical diplomats, traveling the bloodstream, issuing orders, resolving nothing quietly. Still, sometimes, late in the cytosolic night, you wonder, what if I ignored them? Just once. And then you remember what happened last time you didn't respond to thyroxine. It wasn't pretty. So you adjust your receptors, brace for the next message, and do what cells have always done. Obey the floating molecules with big ideas and bigger egos. Hormones are the posh diplomats of the body. They take their time. They float, they glide, they influence. But neurotransmitters? They sprint. They're like chemical text messages sent in all caps at 2 a.m. Immediate, insistent, and almost always emotionally charged. You've barely metabolized your last protein when, bam, a tiny molecule slams into your receptor. Glutamate, maybe. Or dopamine. Or something slightly unhinged, like norepinephrine. No pleasantries. No context. Just zap. Excite now. Or zap. Inhibit this instant. You're left standing there, receptor still buzzing, wondering what just happened, and whether it was your fault. The speed is relentless. Neurons fire. Neurotransmitters release. You're suddenly managing an influx of sodium ions, blocking potassium channels, or worse, trying to balance serotonin. It's like someone gave your membrane a pager and forgot to show you the off button. You try to focus. Maybe keep your resting potential somewhere reasonable. But they keep arriving. Little packets of chemical suggestion. Some excitatory, some inhibitory. All incredibly sure of themselves. You ask, can I finish processing that GABA message from 3 seconds ago? The next neurotransmitter throws open the receptor and yells, too late! It's dopamine time, baby! It's exhausting. They don't care if you're a muscle cell or a gland or a neuron with a family. They've got a message. And they expect you to do something with it. And fast. You learn not to take it personally. Not every glutamate surge means you're in danger. Not every acetylcholine whisper is the start of a crisis. Sometimes the messages contradict. Sometimes they layer on top of one another like emotional lasagna. You try to smile. To be polite. To let the neurotransmitters flow through you like passing weather. But deep down, you're just trying to keep your ion channels aligned. And not overreact to the chemical equivalent of you up? Still, there's something beautiful in it. This instantaneous choreography. A system so fast, so twitchy, so precise, that entire thoughts are born and processed in the time it takes you to open a calcium gate. You don't always understand it. You don't always like it. But you do your job. You receive. You respond. And you let the messages pass through you, not as judgments, but as the strange, twitchy love language of the nervous system. It begins subtly, a shift in the membrane tension, a protein receptor twitching like it's overheard something scandalous. The cytoplasm stiffens. You don't know what's happening, but something is wrong. And then, the signal hits. A whisper at first, invader. Then louder, pathogen detected. And just like that, your peaceful cytosolic life is over. Welcome to the drama of the immune system. Suddenly, you're surrounded by panic. Cytokines yelling instructions you don't fully understand. Macrophages on the radio. T-cells flexing like they've been waiting their whole molecular lives for this moment. You glance toward the membrane. Yep, there it is. A bacterium. Ugly. Spiky. And entirely too confident. It bumps rudely against your surface like it owns the place, spitting out toxins and duplicating faster than your Golgi can handle. And your immune system? It lives for this. Out of nowhere, natural killer cells arrive, armed to the mitochondria and absolutely thrilled to be involved. They don't ask questions. They don't fill out paperwork. They just start launching perforin like it's a molecular fireworks show. And if you think that's intense, wait until neutrophils show up. They're not subtle. They explode. Literally. They throw themselves at pathogens in suicidal waves, leaving behind a trail of enzymes and vaguely accusatory debris. You, meanwhile, are trying not to get caught in the friendly fire. "Excuse me," you whisper, ducking under a phagosome. "I live here." But it doesn't matter. In this moment you're either a helper or a suspect. You try to cooperate. You display some antigens. You offer up bits of suspicious protein. You even wave a major histocompatibility complex like a nervous citizen showing ID at a security checkpoint. Still, the T-cells circle. One of them looks at you sideways. Where were you between the last two divisions? You want to say, minding my endoplasmic reticulum, but instead you just hold up your self-markers and smile awkwardly. Eventually, if you're lucky, the invader gets tagged. Swallowed. Digested. The antibodies throw a party. The macrophages tidy up. And the drama dies down. But long after the last cytokine has floated off, long after the lymphocytes have left the scene, you're still rattled. You learned something today. That your peaceful little world lives right next to chaos. That being a cell isn't just about floating and dividing. Sometimes. It's about surviving. And hoping, fingers crossed, receptors aligned, that next time, the immune system remembers you're one of the good guys. You wake up one cytoplasmic morning, thinking everything's fine. Peaceful. Stable. You're a well-adjusted cell. Hydrated, folded, and functioning. Then, something drifts in. Not a virus. Not a bacterium. Not even a fungal spore with ambition. Nope. It's pollen. Just a microscopic grain of tree confetti. Floating along, minding its own business. Looking, frankly, adorable under a microscope. And then it happens. A sentinel cell spots it, probably a mast cell, because of course it's a mast cell. The neighborhood busybody of the immune system. And it panics. Dramatically. You hear the signal. Foreign object detected, all units, respond with maximum overreaction. Wait, what? You blink. Even your mitochondria pause. You check the pollen again. It's just sitting there. Doesn't even look suspicious. But it's too late. Histamine is released like someone's smashed open the emergency candy jar at a birthday party. And now, Now the whole system is sneezing, swelling, itching, and inflaming itself into a frenzied mess. You look around your membrane, baffled. Is this really necessary? Apparently yes. Your capillaries dilate like they're preparing for battle. Mucus production skyrockets. Your epithelial neighbors start puffing up like alarmed balloons. It's a full-blown histamine festival. And you, a completely innocent cell, are caught in the center of the chaos. You try to protest. Friends, that was literally a flower molecule. But the immune system does not negotiate with imaginary terrorists. It reacts. Violently. Repeatedly. Meanwhile, eosinophils arrive, late and overly dramatic. Ready to attack something, anything. Even if they're not sure what it is. You spot one sharpening its enzymes, like it's prepping for a duel with a rogue pinecone. Allergy responses are not elegant. They are not reasonable. They are a chaotic storm of well-meaning defense systems, overreacting to harmless things with the energy of a bad medieval courtroom drama. Eventually the antihistamines roll in, calming everyone down like molecular librarians. Shh, enough now. Breathe through the cytoplasm. The inflammation ebbs. The panic fades. The pollen? Still there, completely unfazed, floating smugly like the agent of chaos it never meant to be. And you, poor cell, just want a nap. Maybe a warm vacuole bath. Maybe a moment where your own body doesn't throw an opera every time spring arrives. You sigh. At least you didn't get involved in the peanut debacle. You've heard stories. There are misunderstandings. And then, there's autoimmunity. One moment, you're just living your best cell life. Absorbing nutrients, folding proteins, staying in your membrane lane. And the next, your own immune system decides you look suspicious. It starts subtly. A few receptors glance at you funny. A macrophage gives you the cold cytoplasm shoulder. A T-cell passes a little too close to your endoplasmic reticulum without saying hi. You ignore it. You're a law-abiding, ATP-generating, antigen-presenting member of this body. You have markers, for nucleus sake. But then comes the first attack. Antibodies. Pointed at you. Your surface proteins, the ones that scream, "Hey, I belong here," are now being flagged as hostile. You stutter. I'm self, I have ID. The immune system squints. Sounds like exactly what an invader would say. And just like that, you're officially on the no-fly list of your own body. B-cells start mass-producing antibodies with your name on them. Cytotoxic T-cells queue up at your membrane with serious breakup energy. Even natural killer cells, who used to smile at you during interstitial traffic, now avoid eye contact. It's a betrayal that runs deep. You're not just being attacked. You're being gaslit by your own defense squad. Every surface marker you proudly wore now seen as incriminating. Every friendly signal you send twisted into proof of guilt. You try to explain. Maybe you've changed a little. Maybe a virus got involved once and left some residue. Maybe your MHC complex threw a tantrum and presented the wrong peptide at the wrong time. It happens. But the immune system is not feeling reasonable. It doubles down, launches more T-cells, mobilizes complement proteins. And before you know it, tissues are inflamed, organs are annoyed. And you're sitting there, innocent, in the cytosolic ruins of a case of mistaken identity gone rogue. It's confusing, lonely, and ironically, you feel sicker than ever. Not because of an invader, but because the very system designed to protect you has decided to take you out. And the worst part? You're still trying to help. Still processing. Still folding proteins and maintaining ion balances like the loyal cell you are. All while dodging antibody punches. But that's autoimmunity for you. A twisted tale of overprotective biochemistry. A system so good at defending itself, it sometimes forgets what self even means. And you just keep floating, doing your job, holding on to the hope that someday the immune system will remember your face and maybe, just maybe, apologize with some anti-inflammatories and a hug. Mitosis. The cellular version of copying and pasting yourself, but with chromosomes, checkpoints, and just a hint of existential dread. You didn't ask for this. You were happy, floating around, minding your lysosomes, digesting occasional invaders and sipping nutrients like a well-behaved little blob. But now it's time to divide. Apparently you've outgrown your cytoplasmic shoes. Resources are stable, the neighborhood is quiet, and the body's whispering, "More of you, please." So you do what all good eukaryotic cells do. You commit to mitosis. But here's the thing. It's not fast. It's not flashy. And it's certainly not casual. This is a 6-phase, full-body event involving coordination, choreography, and a lot of internal pep talks. You begin with interphase. It's not technically part of mitosis, but you can't just go charging into chromosome chaos without doing your homework. First, DNA replication. 2 copies of your entire genetic library. Carefully proofread, double-checked, and lovingly coiled like a pair of microscopic sleeping bags. Then, your organelles prep. Centrosomes duplicate, and the cytoplasm stretches slightly like it's adjusting to maternity pants. By the time prophase rolls around, things are getting real. Your chromatin condenses, tightening into X-shaped chromosomes like it's dress rehearsal at the nucleus opera. The nuclear envelope starts pulling back. I'm not crying, you're crying. And the centrosomes begin migrating like they've got somewhere very important to be. Then comes metaphase. This is where your chromosomes line up neatly in the center of the cell, as if queuing for the world's most intense passport check. Spindle fibers from either end latch onto their centromeres, tugging gently, like overzealous toddlers trying to get your attention. You're tense. One wrong move, and someone gets 2 copies of chromosome 12 and no copy of 19. No pressure. Then, anaphase. The separation. The part where things get tugged apart like a breakup in slow motion. Sister chromatids, once so close, are pulled to opposite poles. It's quiet, dramatic, and a little emotional. You whisper, "Goodbye, other half of me," as the mitotic spindle pulls everyone to their respective corners. Finally, telophase. The nuclear envelopes reform like they never left. Chromosomes loosen up, shedding their dramatic X-shape. And the cell begins the ultimate mic drop, cytokinesis. The membrane pinches inward. Your cytoplasm divvies up its things. You get a mitochondrion, I get a ribosome. And the actin ring tightens like a belt after a holiday feast. And then there are two of you. Identical. Exhausted. Gently wobbling into the interstitial fluid. Wondering who's going to get stuck doing the next protein synthesis shift. You've just cloned yourself. Perfectly. Elegantly. With barely a misplaced organelle. And while no one applauds in here, you know, deep down, you nailed that division. If mitosis is neat, efficient, and all business, meiosis is well complicated. It's the cell's version of dating with serious intentions. Trying to make something new, something genetically unique, while also ensuring that nothing essential gets accidentally thrown in twice. And the first thing you're told, cut your DNA in half. You blink. Come again. You've spent your whole life replicating DNA, guarding it like the precious double-helixed blueprint it is. Now, suddenly, you're asked to split it, intentionally. Because someone, somewhere, decided reproduction needed surprise chromosomes. Welcome to meiosis. You start with a cell that looks suspiciously like you pre-mitosis. Happy, plump with duplicated chromosomes. Ready to rumble. But this time the goal isn't to make two identical copies. No. This time the mission is to create 4 cells, each with only half the original DNA. Why? So they can team up with someone else's half and make something entirely new. You're not even allowed to complain. You're a gamete now. Kind of. First up, meiosis the first. Here's where things go sideways, literally. You enter prophase I, and immediately the chromosomes start behaving oddly. They don't just condense. They start pairing up with their homologous buddies. Those nearly identical chromosome twins that have been floating quietly in your nucleus for years. And then they cross over. They literally swap segments of genetic code, as if flipping through each other's blueprints and saying, "Nice gene cluster, mind if I borrow it?" It's messy. It's random. It's genetic roulette with recombination sprinkles. By the time you reach metaphase I, these now slightly mismatched pairs line up in the middle. But unlike mitosis, they're lining up as pairs, not single files. And then comes anaphase I, a dramatic pulling apart of these chromosome couples. Not the sister chromatids. Not yet. That would be too straightforward. Instead, whole chromosomes are yanked to opposite ends. Like a highly emotional game of chromosomal tug-of-war. Telophase I follows, then cytokinesis. You now have 2 cells, each with half the number of chromosomes, but double the confusion. And just when you think it's over, meiosis looks you in the membrane and says, "Let's go again." Enter meiosis II. This is basically mitosis without the prep work. No DNA duplication this time, just pure, unfiltered separation anxiety. Chromosomes line up, split their chromatids, and divide again. You go through prophase II, metaphase II, anaphase II, telophase II. You barely have time to hydrate. And then 4 cells. Each genetically different. Each holding a precious, minimalist half set of chromosomes. Ready to go meet another half and start a brand new organism. Hopefully in a situation involving love, candlelight, or at the very least a functioning reproductive system. You, meanwhile, are left standing in your own cytoplasm like, Did I just undergo 2 rounds of division, recombination, and identity reshuffling so some future human could have dimples? Yes. Yes, you did. Welcome to the beautiful, chaotic, and deeply exhausting world of meiosis. Some cells know exactly what they want to be when they grow up. Muscle cells? They're all about flexing. Neuron cells? Constantly networking. Liver cells? Busy detoxing your questionable snack choices since forever. But then there are the stem cells. Stem cells are different. They're the open tabs of the cellular world. Always waiting. Always poised. Always saying, I could become anything. I'm just not rushing into labels right now. It's not laziness. It's potential. You first meet them nestled in quiet corners. Bone marrow, early embryos, skin, the back of your eye. They aren't doing much on the surface. But underneath? They hold the capacity to become nearly any cell in the body. They are the original overachievers, without the social anxiety. There are 2 main types. Embryonic stem cells, the wildcards. They can become any cell type. Brain, bone, gut, lung, even that obscure inner ear balance sensor thing no one ever thinks about. They're called pluripotent, which basically means, I can do literally anything, just give me some biochemistry in space. Then there are adult stem cells, the more responsible cousins. They can't become everything, but they still hold a limited set of skills, and the uncanny ability to fill in when needed. They're like substitute teachers with extremely specific degrees. And here's the thing. You don't become a stem cell. You're either born one or you stay what you are. Stem cells hold this magical property called self-renewal, which means not only can they transform into something else, they can also copy themselves without aging out or forgetting who they are. Imagine duplicating your own potential without losing any. It's enviable. When injury strikes, a cut, a burn, a damaged bit of cartilage, stem cells often come rushing in. Or rather, they're summoned by biochemical whispers. Hey, we need a few skin cells over here. Oh, and a blood vessel lining if you've got the time. And off they go. Dividing slowly, carefully. Taking notes. Choosing destinies. Sometimes they mess up. Occasionally they overdivide. And things go awry. That's how some cancers begin, but we won't dwell there tonight. Most of the time, though, they're miraculous. They sit in the background of life. Rebuilding, refreshing, restoring. The quiet artisans of regeneration. The paintbrushes that never run dry. You watch them, as a humble cell yourself, and think, maybe in another life. But stem cells don't envy you either. They're still deciding what to be. And they're good at waiting. You didn't expect this. You thought being a cell would be quiet work. A bit of floating, the occasional mitosis, maybe a rare encounter with a white blood cell having a bad day. But the talking. Oh, the body never stops talking. Not in words. In signals. Whispers. Tiny bursts of meaning carried by molecules with very strong opinions. Welcome to the endless cellular gossip mill. It begins subtly. You feel a ripple. A protein bumps into your membrane, uninvited. It's not just any protein. It's a hormone. You don't know where it came from. A gland up north, probably. The hypothalamus, maybe the thyroid. Hard to tell, honestly. They're always sending messages, those lot. This one lands with confidence. Sticks to your receptor like it owns the place. And before you know it, your entire internal machinery shifts gears. Because that's how it works here. You, the cell, don't make the plans. You get a signal, and suddenly it's glucose, let's open the floodgates. Time to divide again. Switch to protein synthesis mode, now. You have receptors for all kinds of drama. Insulin glides in like a gentle accountant, asking you to open up and let in some glucose. Because someone just had a banana smoothie. Adrenaline, on the other hand, arrives in a panic, shouting that there's something outside the body with claws, and you should start burning energy like a house on fire. Even estrogen and testosterone drop by now and then. Not so much shouting, more like humming long, slow changes that shift your identity over weeks, months, years. And these are just the major players. The body is full of cytokines, growth factors, and neurotransmitters, all nudging, coaxing, commanding. Each with a specific tone, a molecule-shaped key. A purpose that only makes sense when you're one of billions, trying to hold a single organism together. Cells whisper to each other too. When a neighboring cell gets injured, they send inflammatory signals. Tiny messengers, some polite, some aggressive, rushing over to say, "We need help." Also, everything is on metaphorical fire. And you? You listen. You process. You respond, sometimes calmly, sometimes like a panicked intern during your first week on the job. And you send messages of your own. Sometimes it's a quiet nudge to your neighboring cell. Psst, time to grow. Other times, it's a more desperate transmission. We're out of oxygen down here. Even your membrane proteins get involved. Standing like doormen, checking signals, letting only the right ones through. But no one ever says thank you. Because here in the body, communication is constant, chaotic, and most shockingly, efficient. It's not about feelings. It's about balance. Survival. Adapting fast. You don't have a voice, but your receptors speak for you. You don't have ears, but your whole membrane listens. And in this strange, crowded, multilingual world of the human body, you are always in the loop, whether you like it or not. Inside the human body there are two main communication empires, the nervous system and the endocrine system. And let's just say, they've got very different vibes. Brain, the nervous system. Fast, sharp, impatient. If this system were a person, it would be the type who taps their foot waiting for the microwave. It likes instant results. Nerve cells, called neurons, fire off electrical impulses like gossip texts in all caps. Zap. The hand pulls away from the hot pan. Zing. The eyes blink just in time to avoid a speck of dust. Everything is measured in milliseconds. You're not usually part of this circuit. You as a humble body cell aren't in the neural high-speed train. But you hear about it. When the nerves fire, your nearby neighborhood, muscle, skin, gland, gets the message. It's not subtle. It's more like, ACT now, move, jump, sweat. These messages are short-lived, on demand, and usually dramatic. No reflection, no nuance. Just go. Now contrast that with anatomical heart, the endocrine system. Slow, strategic. The endocrine system doesn't yell. It sends messengers, hormones, floating leisurely through the bloodstream, like handwritten letters on scented paper. Hormones take time. They don't care if it's urgent. They care if it's important. Growth, puberty, metabolism, sleep cycles, pregnancy. These are not things you rush. These are projects with flowcharts. And when these messages finally arrive at your membrane, they stick around. You're not just on alert, you're changed. Reprogrammed. Sometimes forever. The thyroid might send thyroxine, and suddenly your metabolic rate shifts for the season. The adrenal glands might whisper cortisol, and you, already tired, become even more convinced that everything is stress. And then there's melatonin, the sleepy time postman, tiptoeing in as night falls to say, "Shh, it's time to start shutting down." Unlike the snap judgment texts of the nervous system, these hormone messages linger. They set the mood. They adjust the thermostat. They play the long game. So who's in charge? Well, both. Sometimes the nervous system activates the endocrine system. Like when you're scared, and your brain shouts, "Release the adrenaline!" And the endocrine glands do, and suddenly your heart is racing and your palms are sweaty and you're Googling how fast one can run from a mildly aggressive goose. Other times it's the reverse. Your hormones influence your brain. Quietly, slowly. Nudging your thoughts, your feelings, your energy levels. Yes, this is why you cried at that commercial about the lonely robot. And in this web of fast zaps and slow waves, you, the cell, stand there, receiving it all. Sometimes trembling. Sometimes transforming. Always listening. Always adjusting. Because whether it's a lightning bolt of neural chatter, or a molasses-slow hormonal breeze, the message is always the same. Stay in sync. Keep the body alive. Don't mess it up. Here's something they don't tell you when you wake up as a cell. Your entire identity, your safety, your survival, your sanity, depends on a thin, shimmering, wiggly membrane. It's not flashy. It's not thick. It's not even technically alive. But your cell membrane is everything. Think of it like an exclusive velvet rope lounge. Not everyone gets in. Not even most. Just the ones with the right passcodes, the right shape, or the right chemistry. At its simplest, it's made of a phospholipid bilayer. A double layer of fat molecules with attitude. Each of those molecules has a water-loving head and a water-hating tail. So they line up neatly. Heads facing out, tails tucked inside like introverts at a party. The result? A soft, flexible, self-sealing barrier that somehow manages to protect everything inside you. Let nutrients in, keep toxins out, and still allow you to breathe, eat, and receive messages, all without opening the floodgates. Honestly, it's impressive. But here's the thing. This barrier isn't just some static wall. It's selectively permeable. Which is science speak for. Some stuff can come in, other stuff can't, and I'm not explaining myself. Let's talk access. Ice simple diffusion. If you're small and nonpolar, like oxygen or carbon dioxide, you just drift through. No one stops you, No bouncer, no paperwork. You're the quiet guest who slips in unnoticed. Droplet-facilitated diffusion. Slightly bigger molecules, like glucose or ions, need help. They show up at the door looking eager, and if they've got the right credentials, a friendly protein channel opens and lets them in. Some of these channels are picky. Some open only when the body says so. Some require a tiny electric jolt, or a change in pH, or the moon to be in Capricorn. Okay, not that last one. Probably. Door active transport. Then there are the VIPs. These guests don't just stroll in. They require energy, ATP, the molecular currency of effort. They're like guests who bring too much luggage and demand an elevator ride. Special protein pumps escort them across the membrane, using your cell's precious energy stores just to get one sodium ion to its proper side of the door. You do it because the gradients must be respected. Because homeostasis is everything. Because if the balance of ions goes off, everything collapses into cellular chaos. You've also got endocytosis and exocytosis. For the really big cargo. Endocytosis is when you swallow something whole, wrapping your membrane around it like a slow, gooey hug. Exocytosis is when you spit something out, usually waste or messages, or leftover bits of unwanted protein gossip. And all the while your receptors hover near the surface, eavesdropping on passing hormones, neurotransmitters, and the general chemical ambience of your environment. They don't let just anything in. Nope. These receptors have types. Only molecules with the exact right shape can dock, ring the bell, and deliver the message. A little off? Wrong shape? No entry. Try again later. It's not rudeness. It's survival. Because your cytoplasm, the rich goo inside you, is sacred space. It's where all the work happens. And your membrane knows this. So it curates your experience with the snobbery of a high-end doorman and the calm wisdom of a Zen master. In a way, your membrane is you. It defines your edges. It decides who gets close. It lets in just enough of the world to keep you informed, but not enough to drown you. You spend a long time just resting there, gliding through the bloodstream, eavesdropping on signals, filtering visitors, keeping your world small, safe, and perfectly balanced. And maybe, just maybe, if you're lucky, you'll get through the night without a single protein miscommunication. If cells had a neighborhood hierarchy, mitochondria would be the overcaffeinated homeowners with 6 solar panels and a backup generator. Always humming. Always just finishing one more task. Always a little too invested in your metabolic rate. They're not large. They don't take up much space. But oh, do they matter? Let's start with the basics. Mitochondria are the power plants of the cell. That's the line in every biology textbook, and technically, it's true. But it doesn't quite capture the full picture. Because mitochondria aren't just quiet little energy engines. They're former free-living organisms, tiny bacteria who, millions of years ago, got swallowed up by a bigger cell and never left. Instead of digesting them, the larger cell said, "Hey, wait a minute, you're kind of useful." So they struck a deal. Symbiosis. The mitochondria got protection and food. The cell got something much better, ATP. the universal battery of life. And so they stayed. Forever. Like a roommate you didn't plan for, but who pays all the electricity bills. Now, here's where it gets weirder. They still have their own DNA, separate from the nucleus, passed down maternally. Tiny loops of genetic memory that whisper, "We weren't always part of you." And yet they're essential. Without mitochondria, your cell is just a wet bag of hope. With them, you're a metabolic machine. Every time you eat food, say, a banana or a slice of cake, or whatever dreamy snack you imagined before falling asleep, your body breaks it down into glucose. That glucose, it's handed to the mitochondria like an envelope full of potential. Inside the mitochondria, the real work begins. Cellular respiration. A beautifully complex series of steps involving enzymes, molecules, ions, and electron transport chains that stretch longer than your patience. But what comes out is clean, usable ATP. It fuels everything. Movement, repair, thought, dreams, even the effort of hearing your own heartbeat in the quiet of night. And yet, mitochondria don't always play nice. They're efficient, yes, but moody. Push them too hard, and they release reactive oxygen species. Little bursts of chaotic energy that can damage your DNA, age your tissues, and contribute to just about every disease with a scary Latin name. They're also the ones who decide when a cell should quietly bow out. Yup. Mitochondria help trigger apoptosis, programmed cell death. Like lighting a gentle closed-for-business sign inside the membrane. When something goes wrong inside you, and the cell is beyond saving, the mitochondria step forward and say, "This is fine, we're shutting down." Not with violence, with quiet elegance. And that's the contradiction of mitochondria. They give you life. They power your every breath. They can end you, gently, if needed. They are the tiny tyrants, the benevolent overlords, the organelles who never asked for this job, but are doing it better than anyone else. And tonight, as you rest in your quiet cytoplasmic corner, you can feel their low hum. Steady, faithful, and just a little judgy. You owe them everything. And they know it. There's no salary, no paycheck, no daily log. No one hands you a raise. And yet, inside your cell, you are constantly spending. Spending on repair. Spending on thinking. Spending on blinking. And the currency. ATP, short for adenosine triphosphate. Sounds fancy. It's just a small molecule. Tiny, really. But with 3 high-energy phosphate bonds and one heck of a temper. You see, ATP is a bit like a tightly wound spring. A coiled bundle of chemical energy that's just dying to be released. All it takes is a small enzyme, a little biochemical nudge. And snap, off goes one phosphate group like a cork popping from a very energetic bottle. That release. That's your energy hit. That's the fuel for your cell's to-do list. Every time a protein folds. Every time a sodium ion is pushed across the membrane. Every time you regenerate a bit of DNA, you're spending ATP like it's on sale. And trust me, you burn through it fast. Your body generates and uses its entire weight in ATP every day. Yes, you read that correctly. Your weight in ATP every day. You're not just alive, you're an energy economy. Here's how it works. Glucose comes in. The mitochondria break it down through glycolysis, then pass it off to the Krebs cycle, also known as the citric acid cycle, but no one calls it that unless they're trying to impress a textbook. This process produces some ATP. But the real fireworks happen in the electron transport chain, a shimmering escalator of molecules that pass electrons like hot potatoes, all while pumping protons and creating a kind of electrochemical pressure cooker. At the end of it all, a molecular machine called ATP synthase spins like a tiny turbine, powered by the flow of protons, churning out ATP like a factory on deadline. It's elegant, it's efficient, and it's loud, in the quietest, most biochemical way. Now here's the slightly unfair part. ATP doesn't last long. Once it loses that third phosphate and becomes ADP, adenosine diphosphate, it has to be recycled. Thankfully, your mitochondria are on the case, picking up ADP and reattaching another phosphate to make it shiny and spendable again. And this cycle never stops. Even while you're sleeping, even while you're listening to this, your mitochondria are in the back, flipping ATP like short-order cooks during a breakfast rush. Without it, you'd freeze. Literally. Not in temperature but in function. No energy means no transport, no signaling, no repair, no action, no thoughts, no dreams, no anything. And so, the cycle continues. Quiet, relentless, and deeply respectful of how hard it is to be alive. And there you are, floating peacefully in your cytoplasmic cradle, surrounded by humming mitochondria, basking in the warm glow of ATP transactions. You've become a silent participant in the economy of existence. And for tonight, that's enough. Deep inside your mitochondria, beneath the curling membranes and energy-churning machinery, lives something unusual. Something ancient, stubborn, and quietly proud. Its own DNA. Now this might not sound like a big deal, until you realize how weird that really is. Every other part of your cell follows the rules. All instructions go through the nucleus. All genetic blueprints, stored and guarded in the nuclear DNA, like a castle library wrapped in protein guards and carefully labeled scrolls. But mitochondria? They said, thanks, but we brought our own. They still carry a tiny circular strand of DNA, called mtDNA, short for mitochondrial DNA. And it's a relic. A dusty, well-worn passport from a time before you were even you. You see, once upon a very ancient time, billions of years ago, in the primordial soup of microbial ambition, your ancestors were just single-celled blobs, floating aimlessly. Then one blob swallowed another. That swallowed blob, it was a bacterium, capable of producing vast amounts of energy. And instead of being digested, it struck a deal. I'll stay, I'll power you, you protect me, we'll call it even. And so the endosymbiosis began. Mitochondria became permanent residents. They unpacked. But not completely. They kept a few of their original genes, just enough to run their machinery. The rest? Over time, they moved in with the nuclear genome. But a few crucial ones, about 37 in humans, remained behind. Why? Well, scientists are still debating that over cold coffee and conference panels. Some say it's about speed. Mitochondria need to make decisions quickly, especially under stress. Others think it's about control, keeping just enough autonomy to manage their little empire, while still playing nice with the rest of the cell. But either way, the result is this. Every mitochondrion carries the echoes of a time when it ruled its own world. And inside your body right now, millions of mitochondria still whisper that story with every breath you take. Now here's a twist. Mitochondrial DNA doesn't come from both parents. It comes almost exclusively from your mother. That's right. Your mitochondrial DNA is a direct hand-me-down from your maternal line, stretching back generation after generation, like a glowing thread sewn through time. If your mother gave birth to you, and her mother to her, and her mother to her, then every single one of them carried the same mitochondrial DNA line you have right now. This makes mtDNA a favorite tool of genetic detectives. Anthropologists use it to trace ancestry, to map ancient migrations, to uncover hidden branches of the human story. You, a simple, humming cell, carry a record of your past inside your energy center. Not metaphorically, literally. And here's the slightly unsettling part. That DNA, it mutates too. Slowly, subtly. As if adding footnotes to an ancient book. Most mutations are harmless. Some can lead to mitochondrial diseases. A few are just quirky little edits. Unique variations that say, I was here, I lived, I passed this on. So tonight, as you float lazily through your cytoplasmic chamber, you're not just resting. You're carrying a legacy. One written in spirals, preserved through millennia, nestled quietly inside your mitochondrial heart. No need to thank your mitochondria. They know. If you ask a human about death, they'll likely tense up. It's loud, sudden, final. Wrapped in fear, mystery, grief, and unresolved to-do lists. But inside the body, cells treat death more like a polite resignation letter. A well-timed curtain call. A thank you for your service moment followed by a smooth fade to black. It's called apoptosis. Not quite death. Not quite decay. More like a slow, elegant retreat. See, sometimes a cell just knows. It's damaged. It's old. It's made one too many typos in its DNA. Or it simply isn't needed anymore. And instead of lingering, causing harm, or turning rogue, it chooses to self-destruct. But don't imagine a messy meltdown. This is no explosion, no splatter. This is a ballet. The cell begins to shrink. Its nucleus condenses. The outer membrane bubbles into neat little packets, like biodegradable Tupperware. Then phagocytes, your body's cleanup crew, gently consume the bits, recycling the pieces for future use. Nothing wasted. Nothing dramatic. Just a clean, silent bow. And it matters. Oh, it matters. Without apoptosis, you'd be a walking traffic jam of malfunctioning cells, refusing to move on. Your fingers would be webbed. Your immune system would attack itself. And cancer? It's often just cells refusing to say goodbye. Apoptosis is how your body stays fresh. It's how your immune cells retire after the war. How your skin renews. How your body whispers, "Thanks, but we're good," to the cells that have served their time. And in this moment, as you float weightlessly through the cytoplasm, you notice something. A neighboring cell, one you've never spoken to, has begun the process. You don't panic. There's no alarm. Only a faint shimmer, a soft retraction of energy, a signal that says, "It's time." The cell curls inward like a sleeping cat. Membranes seal. Packets form. And soon, it's gone. Not with sorrow, but with grace. And you? You feel the shift. The quiet respect. The gentle reminder that even in endings, there's order, purpose, beauty. Apoptosis isn't a flaw in life. It's a feature. A safeguard. A pause that makes room for beginning again. And perhaps, in your own human body, as you lie still in bed tonight, suspended in thought and calm breathing, you too can feel the slow, thoughtful rhythm of letting go. The breath that softens. The thoughts that fade. The stillness that arrives. Not to end anything, but to carry you gently into the next stage. Sleep, perhaps. Or something very much like it. Let's be honest. Not everything in life wraps up with gentle piano music and a thank you note. Sometimes, it's a slammed door, a fire drill, a pile of unexpected consequences, and absolutely zero cleanup crew. In the world of cells, that's called necrosis. And necrosis doesn't knock. It bursts in, muddy boots and all, shouting, "Something's very wrong." Where apoptosis is orderly, necrosis is chaos. It happens when a cell is hit hard by trauma, toxins, infections, or sudden lack of oxygen. There's no time to prepare. No little membrane bubbles or tidy DNA packing. Instead, the cell swells. The membrane ruptures. Its insides spill out into the neighborhood like an uninvited soup. And that's when things get testy. Because now, the immune system gets involved. It sees the mess and goes into defense mode, assuming something's invaded. Inflammation rises. White blood cells swarm. Signals get scrambled. And all because a cell died rudely. Imagine a quiet apartment building, peacefully winding down for the evening. Then one tenant decides to throw a flaming couch out the window and set off the sprinklers. Everyone's affected. Even the ones who had nothing to do with it. That's necrosis. And while it's not ideal, it's sometimes unavoidable. A blocked artery. A venomous bite. A sharp blow to the tissue. All can result in cells simply breaking down, dumping enzymes where enzymes should never be, and turning their surroundings into a biochemical crime scene. Now let's bring this back to you. A quiet little cell, floating in your cytoplasm, minding your molecular business. You feel it. Somewhere nearby, something has gone wrong. Not in your cozy corner, not in your well-regulated cytosol, but in the tissue over. Perhaps a patch of skin, maybe a tired bit of muscle. The signals arrive like static. Cell walls rupturing. Chemicals leaking. Immune cells charging in like irritated bouncers at a late-night brawl. You feel the ripple of it. Not fear, but awareness. A soft internal hum that says, "This isn't how we like things to end." Necrosis is nature's emergency stop button. It doesn't ask for permission. It doesn't care for grace. But when the threat is real, sometimes brute force is all there is. Still, your world remains calm. You are safe, unruptured, intact. Necrosis may rumble in the distance, but here, in your plasma-laced world of order and breath and repetition, you are held, protected by layers of membrane, process and routine. And maybe, just maybe, you feel a little more grateful for all the times your body gets it right, all the times your cells say goodbye with dignity. There's something quietly magical about beginnings. Not the loud trumpet blaring kind, but the slow, steady, almost timid sort. The kind that happen when no one's watching. In the human body, that quiet miracle lives in stem cells. While you, a fully grown and deeply employed cell, spend your days digesting, defending, dividing, or simply floating along, stem cells stay in a kind of suspended possibility. Undecided. Untitled. Not yet a skin cell or a neuron or a red blood cell. Just a stem cell. Patient. Waiting. Uncommitted. They are the blank pages in a well-thumbed novel. The choose-your-own adventure before the first path is picked. And when one of you fades, when a cell in the liver quietly bows out, or a patch of skin flakes away in the shower, or a white blood cell exhausts itself fighting a fever, stem cells answer. Not with noise, not with fanfare, just with a decision. I'll become that. A liver cell, a skin cell, a new defender. Stem cells are the ultimate shapeshifters. They divide slowly, carefully, and when the time is right, they commit. And suddenly, there's renewal. In a way, it's the body's way of saying, "It's okay, we've got this." Because while a single cell's story may end in tidy apoptosis or clumsy necrosis, the tissue lives on. The system adapts. The cycle continues. And deep in the soft quiet of your body, birth and death happen side by side, without drama. Now here you are, still floating, still intact, perhaps a little wiser now. You've seen the mechanics, the messes, the miracles. You've learned that even in the smallest space, there's rhythm, order, odd humor, and purpose. Maybe you're still in your cell body, gently rocked by the currents of cytosol, watching the mitochondria hum and the lysosomes tidy up the corners. Or maybe, just maybe, you're somewhere deeper, slipping into stillness, as even your thoughts start dissolving like proteins into enzymes. The story doesn't stop. But for now you do. Quietly, softly, and with all the grace of a cell that knows when to let go and when to rest. So there you have it. You've lived an entire life as a single human cell. Not bad, considering most of them don't even have a clue what's going on. You navigated traffic in the bloodstream, got nudged by some platelets, avoided full-on immune drama mostly, and even witnessed the graceful and not-so-graceful ways a cell can say goodbye. It's funny, really, how something so small, so quiet, and so often overlooked, can be the stage for such a strange little epic. And maybe, as you lie still now, cozy, safe, somewhere warm and dark, and far from anything like a lysosome, you can feel the rhythm of it. That steady, humming background life your body's been carrying on without your help. Your trillions of cells, clocking in, clocking out, eating, recycling, dividing, dissolving, all while you nap. So as this journey winds down, there's nothing more for you to do. No membranes to hold together, no pathogens to avoid, no receptors to decode. Just rest. Let the cytoplasm swirl. Let the enzymes hum. Let yourself be carried, cell by cell, into sleep. And if your dreams take you back into the bloodstream, maybe give the macrophages a little wave. They've earned it. Good night, little cell. You've done enough.